uh, I just want to lead into this and say this is a 45-minute session that I'm already using up some of the time of. So I'm going to move very quickly. And I apologize for that, but I know this is being recorded. You could always watch it later. But I want to make sure I can cover as much information as I can in the time that we have. So just to get started, I thought we would go with a brief history lesson that will hopefully help explain some of the background and the reasons and the context for what ultimately led to clean architecture. All right. So back in the 20th century, a whole different century ago, uh, the predominant way in which many applications were written, especially business software, was this idea of client server architecture. And client server architecture, like the name implies, is very simple. You've got a client system, some client application, and it needs to talk to something to do persistence, right? And so it has some database server typically behind it. And in this time, in the 90s, when I was first getting started in professional software development, data was really the king of all the things that we were working on. There was a huge number in this time of application development frameworks that were essentially just a forms engine wrapped around a particular database implementation. And so you may be familiar or have heard of many of these things, everything from Microsoft Access and Fox Pro to DBase, Clipper, FileMaker Pro. All of those were examples of we have a database. Let's give you some user interface on top of that database so that you can mess with the data. And of course, in addition to these sort of desktop database systems, there were a lot of database servers coming online as well. And so you had most of these players are still around today. You've got Oracle and Microsoft and IBM and others. And these were the big, expensive, dedicated database systems that larger enterprises would use. And these basically the data in these databases, just like today, was considered to be the company's crown jewels. It was very precious. And so there was this additional professional that's still around today called the database administrator. And they were the folks who were charged with keeping all of this data safe and accessible and backed up. And they were very protective, rightfully so, of the database server. And so if you were a developer, especially a inexperienced new grad college developer coming onto the scene in this time, you would experience that you didn't have much ability to actually have your own database or work with data directly. You had access of whatever was granted by the database administrator, who wasn't usually in a very forgiving mood because developers tended to mess up the data in many situations. And so what ended up happening in this time was that, especially in the 90s and early 2000s, everything was very database centric and very data driven. And the most important thing was that databases were performant, that they were as inexpensive as possible. And so, things like the Y2K bug were a result of the expense of storing data. And so, we only stored 2 characters or 2 digits of years instead of 4. And that meant that when things flipped over to 00, bad things might happen. Um, all of that was, again, centered around how the database worked and how it was the center of so many things in the software space. Now, early architectures understood that a lot of the code that you were writing would be better if it were organized into some types of layers. And so the early approaches were things like this N-tier layered architecture that many of you have probably heard of or seen or used. And in fact, this was super popular at the beginning of the 2000s. In fact, my very first conference presentation, which was for, I'm actually at a conference right now this week, which is why I'm in a hotel, was on N-tier architecture, and it was at this same event essentially. Dev Connections. Now it's Dev Intersection, but in 2001. Right, so it's been around for 24 plus years. I'm sure even in the 90s, before I talked about it, this was a thing. However, the way that this layered architecture typically was implemented did not use some of the things that we take for granted today, like interfaces or other abstractions or things like dependency inversion. And so what ended up happening is everything ended up transitively depending on the database. And that resulted in just the whole system needed the database all the time. And again, at this time, the database wasn't on your machine in most cases, right? The database was this highly coveted and expensive resource that your enterprise maintained on your behalf and gave you limited access to. So having everything in your application depend on that database was often a limitation. Now, around the same time, late 90s, uh, and inside of the early 2000s, other things were happening, right? Like Agile, and the Agile Manifesto, extreme programming, moves toward quality and being able to improve ourselves as a craft or as an engineering practice were also happening in the software development industry. And so we were maturing. And so things like unit testing started to become more important. And so we wanted to be able to write unit tests. We wanted to be able to have them run quickly. We started to first do continuous integration. Prior to continuous integration, which most of us just take for granted now with Azure DevOps or GitHub Actions, right? We had an industry that thought it was okay to go and build software for 6 months and then spend a month trying to integrate all the pieces together to try and ship it. Or there'd be like someone on the team whose job was just trying to integrate all the pieces and get it to actually build. That all started to change about 20 some years ago when cruise control was the first of many systems that would automatically build your software every time you check stuff in. And so as we're getting toward this, one of the things that started to happen is developers would want to write more tests because these tests could be run automatically, and it was a great way to catch errors faster. But the problem was databases made this more difficult, right? And so developers would start asking, how can I test this without hitting the database? And I myself, I recall, 20 some years ago, running into this with the apps that I was building in the early versions of .NET 1.0, with web forms and SQL data adapters, and finding it very difficult to test my application, especially when it wasn't on my machine, right? Especially when it was on the build server. And so that also led into these architectures that started to appear. So the problem was we had a ton of tightly coupled dependencies. In many cases, they weren't well organized. You had user interfaces and controls like drag and drop data accessors that would just drop into your UI in a web forms app and would just make a connection to the database anywhere they felt like it. And so this resulted in just this mess of dependencies. And the goal, of course, was to be able to take control of those and make it so it was something that was easier to manage, easier to understand, and easier to change when you needed to, right? Without breaking everything else. So around this time in 2003, Eric Evans published his great book, Domain-Driven Design, and really started this whole idea of DDD. And with DDD, the whole idea of the book, if you were to break it down, is that you make the business rules the center of the application, not the database, right? And because we have the ability to write software that models a problem, and then to be able to write automated tests that verify that our understanding of how that model works is correct and continues to stay correct over time, right? That became a much more efficient and effective way to deal with complex business rules than trying to do it all inside of the database using T-SQL or something as your programming language. So when this started to happen, databases started to take less of an important role in the application itself. Around this same time and continuing now with Docker containers and things, databases became increasingly cheaper to run on your own developer workstation, right? And so that, of course, helped as well. But once databases became just one of many external dependencies your application might have to work with, other architectures started to emerge. And so it wasn't just that your app talked to a database, maybe it also talked to web services, maybe it had to talk to the file system. All of those dependencies made unit testing very difficult. And so they were all put behind what domain-driven design would call an anti-corruption layer, which would shield your business domain model from these external concerns that would make it more difficult to work with, more difficult to change, more difficult to test. And so over time, instead of having one database to rule them all inside of organizations, you would start to see more and more smaller databases that were perhaps supporting one or two apps instead of all of the systems in the company. So with that came some new architectural patterns. One of the first is one called hexagonal architecture, also called ports and adapters. Ports and adapters is a much more descriptive name. It has to do with the fact that there's ports like this persistence port on the top right and other ports on the bottom left, and then adapters that implement them. Whereas the hexagonal name, I think, is because the original author drew some pictures that look like this, and they said, "Hey, that's a hexagon. Let's use that as the name for the architecture." Probably not the best approach, but it stuck. Um, Anyone wants to produce their own architecture based on geometry shapes, there's still a whole bunch of other ngons that are available. All right, so the main beauty of this approach is that everything in the center in the green, all those entities and aggregates and services, are just pure code, right? They don't have any direct dependency on the outside world. They run in process in your system. And so you can write all kinds of unit tests for those, and they're going to run very quickly, and they're not going to fail because you lost your connection to the database or some file was locked or any of a host of other things that made testing difficult when it depended on external dependencies. So that all led to the new clean architecture style of building systems and keeping those dependencies at a distance. So let's review a few principles real quick before we talk about the specifics of how clean architecture kind of builds on hexagonal. The first one is separation of concerns. Separation of concerns is all about not having things that don't really belong together in the same place in your code. Because when you do, it introduces coupling and it can cause problems with the system and lack of cohesion and other things. So in this picture, which we actually took in our office a while ago, you can see there's things like plungers and Drano in the same place as your food. Hopefully you don't do that in your kitchen. The idea is you shouldn't do that in your code either. All right, so why should we separate concerns? Because it makes those things coupled together if you don't. And so you want to have loose coupling where these concerns touch in a way that makes it modular so that you can swap them out when you need to for testing purposes or in a different environment. Maybe on localhost you want things to run differently than in a staging environment or in production. And it makes it really easy to make those types of changes if everything is modularized and not all coupled together as one big spaghetti code mess. Now, the main three concerns that just about every useful application has are the user interface, the business logic, and the data access. And when all of those are in the same place, it can result in a lot of pain. It makes it much more difficult for you to test. It makes it more difficult for you to change any one of those things without it impacting the others. And so if you can separate those and keep them separated in your architecture and in your system design, it often leads to a system that's much easier to test and maintain and deploy in different configurations in different environments. All right. So if you have a whole lot of things and you're keeping them separated, that naturally leads to another principle from Solid, which is the single responsibility principle. And the single responsibility principle basically says don't couple things together that don't need to change at the same time and for the same reasons. And so SRP, boiled down, basically just says that classes should have a single reason to change. And so if you have a class and it's responsible for several different things, like how do I get the data? How do I format the data? How do I display the data? Right? Those are different concerns and they might change for different reasons if you want to get the data from a different place or if you want to format the data in JSON instead of XML, et cetera. And so by breaking those different responsibilities up into their own classes, it makes your code more flexible and modular and easier to change. Okay. So when you have too many responsibilities in one place, it tends to add coupling and can reduce cohesion, which is how grouped together things are. All right, so it naturally follows that if you're going to follow the single responsibility principle, then your application is going to have more smaller types, right? So if you prefer having everything in one file and your main method of code navigation is your mouse wheel, right, then it's going to be a change for you if you start to follow this particular principle, because now you're going to have to be able to navigate quickly between different files that each have a smaller type in them that only does one thing. So the benefits of following this and having more smaller files are that merge conflicts are extremely rare, and pull requests and commits are much more clear because you can see exactly which files were touched, and that tells you quite a bit about what this change impacted. But it can be more difficult, or at least a different set of skills to navigate a code base that's organized this way. All right, and then the last principle that really plays a big part in clean architecture is the dependency inversion principle, which is the other end of the solid principles. And the dependency inversion principle is all about eliminating that tight coupling, right? This is, as the name says, it's all about dependencies. And that's really the key focus of clean architecture. So the dependency inversion principle basically says that your high-level modules should depend on abstractions, not on the low-level modules directly. Now here, let me just briefly say, what is high level? What is low level? High level is, abstract at the business level of, hey, I've got a shopping cart, I want to add an item to it, right? It says what you're trying to do. Low level says how you're going to do it. And low level might say, I need to load an XML document with the contents of the order or cart element. I need to, then insert an XML element of shopping cart item in this location, right? That's very detail oriented. It knows exactly that we're using XML and we're using the file system, and all the details are in the low level modules. Now, the other part of dependency inversion principle is that your low level modules should also depend on abstractions. The way they're going to do that typically is to act as an adapter and implement an interface to do that. So now these abstractions in C#, these are usually interfaces. They should not depend on details, but instead those details should depend on abstractions. What does that mean? Well, that means if I do make a interface that is all about like adding an item to the shopping cart, I probably don't want that to, take in an XML element and return back an XML document, right? Because, my underlying technology is some XML file. That would make it very tightly coupled to that implementation. Instead, it should just have domain types as its interface. So it might take in an order item and return back an order, and those are high-level abstract things that are part of my business. So then the last couple things with clean architecture is that you want to make the right thing easy and the wrong thing hard. So the goal of really any architecture is to make it so that building that application, if it follows the rules, is going to get whatever the benefits are of the architecture you chose. Now, the main benefit that clean architecture is going for is this loose coupling to dependencies. And so we want to make it easy for developers to not tightly couple the system to those dependencies, and hard for them to do it, to do the wrong thing. And so we're going to lean on the compiler to help us with that and make it so it's, a developer has to really try to break the rules and hit the dependencies directly. And the result of this is that we kind of force developers into the pit of success. If they just do the easiest thing that's the least friction with this architecture, they will go into the right path, is the goal. All right, so the main rule of clean architecture is what's called the dependency rule. And the dependency rule basically says that your source code dependencies should point toward the high-level concerns, the abstractions and the domain model, and the external dependencies and the UI concerns are then kept at the edge of the system, right, pointing inward, instead of the design that I showed with n-tier architecture, where the entire system was pointing outward at the database. All right, so let's talk real quick about domain-centric design, because this ties in nicely with clean architecture. You don't have to follow domain-driven design if you're building things with clean architecture, but it is a really good fit. And so the first part, the central part of clean architecture is your core project or your domain model. And in here, this is where you're going to define the domain classes, right? Things like your entities and your value objects, and the abstractions that you're going to use to interact with those, right? So those abstractions might be things like, persistence abstractions, like repositories. I know repositories have a lot of folks that are fans and that aren't fans, but it's a basic DDD pattern that's in the book that is used to access your domain model if you're doing DDD, and other things, right? There could be domain services, there could be adapters for reaching out to get the system clock or other things. Then in clean architecture, we also add the use cases project in most cases. You don't always have to have this project, but I have found that it is very valuable. A few years ago, I thought it was kind of optional and didn't necessarily add value, but I've come around to agreeing that this is something I'm going to use in every single clean architecture application that I build these days. Now, your use cases project should ideally follow CQRS, which is command query responsibility segregation. And it's going to define messages that are used to communicate with the domain model, right? So it's acting as sort of an in-between with your application, the front end, and your domain model. And so these messages are essentially all DTOs. right? Commands, queries, even events are all examples of data transfer objects typically. And they will then also define actual DTOs that represent your entities. And so ideally, your endpoints, your ASP.NET Core app, when they interact with the use cases project, what they'll get back is not going to be an aggregate or an entity from your domain model. They're going to get back a details object or just a DTO that describes the thing that they were trying to do, so they can then display that to the user or return that from the API. All right, so very quickly, commands, what's the definition? Commands are things that change the state of the system. So inside of a command handler, you're going to have some code that's going to load or create or delete your entities, your aggregates, using abstractions. They're going to work with the domain model through its methods. Ideally, your domain model is not anemic. An anemic domain model is one that doesn't have any behavior, doesn't have any methods, just a bunch of getters and setters. So less value there. If you don't have any behavior in your domain model, then maybe you don't need to be using DDD and all of that to begin with. But assuming that you really do have some complexity in your system, then you're going to have that behavior, and you're going to want to interact with it in your use cases by calling methods that change the state of those entities, and then ultimately save those changes back to the persistent store. Queries, on the other hand, should just fetch those model types directly. If you're using Entity Framework, you typically would do this through, again, a repository if you like, or you could use EF directly. I don't favor that for a bunch of reasons. And then it's going to map those to a DTO. And you can optimize for these because you know in a query that you're not going to be saving any changes. So you can do stuff like make it so you're not tracking those entities when you use Entity Framework in a query, because you don't need that overhead, and you'll save a few percent on performance by doing that. Alternately, a problem that many developers run into, and it's honestly one of the reasons why so many developers are not big fans of the repository pattern, is that if your data doesn't really look like your domain model, like the thing your API endpoint or UI needs is just some ad hoc data query or some search results, right? You can just write a custom query service and put the interface in the use case, implement that in infrastructure, and go fetch the data in whatever way makes sense, right? If the rest of your system is using EF Core and you want to use Dapper to go get the data and bind to some DTO and return it with a query service, you can totally do that. Or EF has the same capabilities to hit SQL these days that Dapper does. And so you don't have to use the repository pattern for everything if you're using it. It makes sense in many cases to use custom query services for things that are just read-only and that need to show data in a certain form. All right, so then we have the infrastructure project, and it defines all of these adapters to talk to any out-of-process communication. The database, again, for historical reasons, is one of the biggest ones that we try to keep at arm's length. But it also includes any other things like sending messages over SMS or email, talking to the file system, even talking to the system clock is something that you might put through an adapter to make it easier to test. These interfaces that it's working from should typically be defined in core or use cases. All right, so then let's talk about this organization one last time. It starts with the domain model. You're going to have the use cases, and they're going to work with the domain model, but they're going to translate it into separate DTOs for the UI. You're going to have your infrastructure adapters. They're going to implement interfaces that are defined in the domain model or use cases. Then you're going to have your user interface project, ASP.NET Core, let's say. It's going to communicate using messages with the use cases. It's usually going to be where you wire up all your dependencies. If you have some bootstrapper project in front of the UI, then it'll be responsible for that. But this is where you say that this interface is being implemented by this adapter. And then your infrastructure is going to talk to out-of-process things, databases, web APIs, whatever, and it becomes the only place where that happens, right? And so this is the whole idea, is that we're making it so that all of the external process communication happens from one place in our code, and likewise, all of the user interface communication happens at the UI project level. And so the domain model, the use cases remain uncorrupted, to use the domain-driven design term, by any of these external concerns. Okay, so what specifically goes in the core project are going to be interfaces, entities, value objects, aggregates, domain services, custom exceptions for things that relate to your domain. Instead of just throwing primitive argument exception or system exception, right? You can define custom ones that are in the language of your domain that will make it much easier for you to figure out what the problem is later when they happen. Because you'll see something like a order not created exception instead of a null reference exception. So don't underestimate the value of custom exceptions is all I'm saying. You may also have domain events. Event handlers could live in the domain. Typically for domain events, that's where they would be. But domain events can also spawn integration events that talk to other systems. And those handlers could live anywhere. You may have specifications. A specification is something that you can combine with repositories to make it so that your repositories don't have that common problem of constantly needing to add one more method for one more custom query, right? Instead, your repository becomes a fixed interface and takes in a specification for certain queries, like get a single item or get a list of items. And now every time you need a new type of query, you just add another specification to your domain model instead of adding another method to your repository or just giving up and returning iQueryable and then having data access scattered all over your application. Not recommended. All right, so now the use cases project has your query interfaces if you've got custom queries. It's got the DTOs of the things that you're returning. So maybe there's a customer DTO or an order DTO. It has the queries and query handlers. It has the commands and command handlers. And that's it. And there are a bunch of advantages to using this approach. One of the biggest being that if you use a tool like Mediator or Mediator, either one of those, they both support pipelines. And in those pipelines, you can do a lot of cross-cutting concerns. And I'll show some examples of that when we get to the code in a moment. In the infrastructure project, you're going to have repositories for persistence. You're going to have web API clients, file access, logging adapters, email, SMS, system clock, anything that's out of process, occasionally interfaces, but only if they are like some vendor-specific interface, like some Azure AWS interface you need to work with. And then the web project has all your ASP.NET Core stuff, right? So depending on what type of project you're building, it's going to have API endpoints. It's going to have view models and binding models and binders and filters and all the stuff that's part of ASP.NET Core. And again, occasionally interfaces, but again, only if they're using the web stuff. If you need to share things between solutions, you might also have a common project. Domain-driven design calls this a shared kernel. And in the shared kernel, I like to have things like base types. And so your base entities, domain events, et cetera, could live here. You could have other things that you've decided your organization is going to use everywhere in there. This can include things like common guard clauses or loggers or behaviors, which again, we'll see in a moment. And that becomes the very lowest thing in the whole system. Okay, so your overall dependency relationship kind of looks like this. At the very bottom, you've got shared kernel. It's really nice if you make this a NuGet package, an internal company NuGet package, because you can version it. And that means that if a whole bunch of different teams are trying to ship and you need something that is getting added to shared kernel, you can add that, rev the version, and ship. And the other team that was also trying to ship today that doesn't have time to incorporate that change doesn't have to deal with it. And they can just continue to ship on the previous version of shared kernel. So that works really nicely. You can see how core and use cases are kind of the next level. And then infrastructure and web are at the top. The web project will typically have a dependency on infrastructure, but it's not actually trying to new up any of those types. It's just using it for wiring up dependencies in program CS or startup CS to associate all of the interfaces with the actual adapters that are going to be used. And of course, if you're using Aspire, which you probably just saw in Jason's talk, all the great things that Aspire has, all those things are kind of part of the web project these days as well. All right, now then you can write tests for all these things. Unit tests work great on core and use cases. Unit tests I define as tests that only run your code, right? They don't have any external dependencies. They don't work with out-of-process things, right? You can run functional tests and integration tests. These functional tests are basically a special case of integration tests where it runs the whole app. And so it's going to use the test host in ASP.NET Core, and it's going to actually interact over an HTTP client in the test. And then integration test is just a term for anything that's integrating a bunch of pieces of your software, But in this case, specifically, things that have external dependencies are going to be what I typically use for defining what goes in the integration test project. All right, so your overall solution structure is going to look something like this. It has about 4 projects that are the main things for clean architecture. In this example, you see we've also got Aspire host and service defaults, and then tests, organize those however you like. I like to keep them separated so that I can run them appropriately, because functional tests tend to take the longest. Unit tests take a few milliseconds, and so I can run the unit tests constantly, but only run the other tests, when it makes sense. Now, some of you have probably heard of vertical slice architecture. And before there was vertical slice architecture, there was this idea of vertical slices. And vertical slices are a thing that you should definitely use regardless of what architecture you might be using, right? And so a vertical slice just basically is the idea that you don't build a whole layer at a time. And so if you're doing n-tier architecture, don't build the whole data access layer before you've built any UI. That's often just a waste of time and it delivers zero customer value. Instead, even if you're building clean architecture, instead of building, your whole domain model and no use cases and no UI and no infrastructure, build a whole vertical slice first and implement a feature that you can get feedback from the customer and verify that it all works, and then repeat that, right? And so as you're delivering software, each thing that you deliver has, all the pieces that it needs, and that's going to be a much better way to deliver value over time than shipping things in horizontal layers, if you will. All right, so I'm going to jump away from this for a minute and get into some code so you can kind of see what this looks like. And so we're going to jump into Rider, and I have a sample application here, and you can find this in my my GitHub repository, Ardalis/clean architecture. And I'll show a link to that in a minute. Now, in here, you can see basically the same structure that I just had in the screenshot. And I've already got this running with Aspire. I really like that Aspire actually shows up in the IDE in the latest JetBrains Rider. That's pretty awesome. And I've got an HTTP file here that I'm going to use to test things. And so this is already running. I should be able to get a list of the contributors here, and that works. And so I've got this page list, and you can see the results down here. It's tiny. We can fetch a specific one. We can add them. We got various things here that I'll show you what they do. The domain here, if we open this up, it's one of the things about DDD and clean architecture is you should be able to tell what kind of application you're looking at by looking at the folder structure, right? And so inside of each one of these projects, it should be really clear what the domain is that we're working with. And so here you would be able to hopefully tell that we have projects and we have contributors. And if we look at what's a contributor, well, a contributor has a contributor who has an ID and a name. Those are some value objects. And then a project has a project and to-do items, right? And so if we look at a project in here, make this over here. All right, you can see it has this list of items, and it has some methods for doing stuff like adding items, updating items, etc. And then if we look at the item itself, you'll see item has a mark complete method on it. And when you call mark complete, we register a domain event, and then that domain event is then handled somewhere else to see if anything else needs to happen, right? And so if you aren't following domain-driven design and you aren't using some of these patterns like domain events, the typical way that you might add one more thing that needs to happen when something happens is to just go into the controller and add one more thing to that action method. Or maybe you've got some giant service that does it, and you would just add one more thing to that method. The nice thing about patterns like domain events is that doesn't happen, right? Your main method in your business logic remains very clean right here, right? It's very easy to test, very easy to see what's going on. And if we then step up to the use cases level, right here, and we go find a use case for a project that says, hey, I want to mark an item complete, right? There's going to be a very simple command that does that, and just takes in a project ID and a to-do item, and then a handler that is responsible for basically using a specification to go and fetch the entity that matches that, and then it's going to call ultimately mark complete on that item, and then update the repository. right? So if you want to unit test this, it's really simple. There's not even a whole lot to try and test except that maybe these results work for when things aren't found. But otherwise, there's not a whole lot of logic there. Now, when you mark this complete and save it, that domain event is going to fire, and then that domain event in this case is going to be responsible for sending emails because somebody cares that this to-do item got marked off and they want to know. And so we can have our event handlers here. I don't want to move things. We can have our event handler right here to say we're going to log this item out and item completed email notification here. Is going to take in a dependency of an email sender and then send this email. All right, so all of that to basically show you what the architecture looks like. I'm not even looking at the web front end because it's trivial at this point. And that's the idea, right? You don't want to have a whole lot of logic in the web app. In this case, I just have a bunch of endpoints. So for a project, the one I'm about to show you is how to mark an item complete. And so if we look at that real quick, this is using fast endpoints, which I'm a big fan of. It's built on top of minimal APIs. It's super fast, and it does a great job of organizing things. Again, with one file per endpoint, so you're not going to get as many merge conflicts or have problems there. And then inside this, there's just a handle method, and it's going to send this command via mediator and then just translate the response back into whatever HTTP status makes sense. Okay, so we'll go back to our API here, and we'll find a project. Where is it? Mark an item to complete. The first item, first project, let's try that. And it worked. And I just got a notification from Chrome, which you can't see, but somewhere over here, I have Papercut running. And Papercut's actually set up in Aspire in my application. So that's how I wired it up. It's just running in a Docker container. And what it did is it caught the email that was being sent because I'm using an SMTP implementation that's just using localhost on port 25. And Papercut is running in Docker, listening on port 25, and gives you this nice UI here. There's a bunch of similar tools. SMTP for Dev kind of does the same thing, but it lets you test email stuff very easily on localhost without sending real emails, which you probably don't want to do. And so all of that worked, which is great. But the nice thing about it is that everything is very cleanly organized, and all the complexity of what are the rules for whether or not something could get completed, where do I send the email, all that stuff is organized in such a way that it is all very testable, and each thing that you would test is very simple, right? You're not going to have stuff that's indented 7 steps in and has 100 lines of code above it that talks to 3 different data stores before you get to the behavior you actually want to test, right? I've worked with a lot of legacy code that looks like that, and it's no fun. So this type of architecture is designed for systems that have too many dependencies to too many external things, and you're trying to fix that and alleviate that pain by putting all those dependencies in one place and forcing everything else in the application to work with those dependencies by using interfaces. It works really well for that purpose. Okay, I guess the only other thing I would show is in the logger, which I don't remember where that is. We're logging out all of the stuff that happened, and that's happening with a behavior. And so in addition to that, we also have a caching behavior. Let me just show you that one. So when I go and fetch an item, if I want to add caching, which can be a huge way to improve the performance of your application, instead of having to go to every single method that's doing some data access and adding some caching logic to it, or going to every repository and adding some caching logic to it, right? By using a mediator pipeline, I can add a behavior, and then I can mark the requests to be implementing some interface. In this case, I made an interface called iCacheable. And if it's not iCacheable, then this behavior doesn't do anything and it just passes through. But if it is, then it's going to get the cache key from that message, which it can generate from the properties on it. So if I have a query that says, give me project ID 1, then that cache key is going to be basically project-1. And that way I won't accidentally return the wrong project to the wrong query, right? And then in here, it just does the caching logic, right? And so this is really simple. It doesn't add any complexity anywhere else. and it just opts in through types, right? Which is a great way to implement your system in a way that's going to be consistent. All right, let me, while I'm in here, show you a couple other things I've got tabs open for. So if you want to see my template for clean architecture and this sample that I was showing, the sample is in the sample folder. It's up to date with .NET 10, even in the latest branch, because I've been updating it. The actual template is still on .NET 9, but it'll rev to 10 in November. You can get the template here in NuGet. You just say .NET New install. There's a few of these, right? And so if you like Jason's talk this morning, he also has a clean architecture template. It's very popular, makes a few different opinions and assumptions. His is 19,000 stars. Mine is 17,500 stars. So his is more popular. So go give mine more stars. And so either way, like, you've got places to start. You don't have to build all this from scratch from an empty solution file. If you want to learn more, there's also a course from NimblePros that you can take. And if you use Ardalis, you get 20% off. And I think that was the only things there. Let me show you one last thing, which is how to use a template. So you just install it, and then you say, in my template, you just say .NET New, Clean Arch, give it a name, and then you'll have that file. And if you cd into it and look at what's there, you've got all the different folders and everything. So if we drop into the source, you can see that it's created all the Aspire stuff, the use cases, the web, everything's there for you. And it's really easy for you to get started. There's some examples of some of the patterns, like the domain events and things like that as well. And so it gives you a good starting point where you're not having to start from zero. All right, so I've got about 2 minutes left. Let me cover a couple more things in the slides, and then we'll take some questions from all of you. So another common question that folks ask is, what about vertical slice architecture? Why do I need all this ceremony of clean architecture when this seems simpler and it's also gaining popularity? Vertical slice architecture, if you're not familiar with it, it's basically feature folders, right? So it's like, take any given feature, any given use case, and put everything related to it that you can in a folder, and then put that folder as close to the top level of your project as you can. So generally, you're just going to have one project. In there, you're going to have your API endpoint, whatever DTOs it's using, any messages and handlers it's using, if it's using some type of mediator strategy, and oftentimes also prefer fewer abstractions. So it's still going to use DI, it's still going to use maybe things like iLogger, but in many cases, folks doing this are like, I don't need an abstraction for data access. I'll just rely directly on the DB context. Some people will try and tell you that that is an abstraction, but it's not, because it's actually a concrete implementation. So the idea with this is put as many things as you can there. Now, some will say that you put everything in each folder, but if you actually look at solution templates that follow this, they don't put everything in there. You're not going to put a separate DB context in every use case to do the data access typically, or have a totally different domain model for every use case, because that would just be a ton of duplication, and it would be hard for you to have any consistency between different use cases or different endpoints. And so things like domain models and DB context, data access, other stuff are still shared. Right, you're going to have like a single global exception handler. You're going to have a single way that you do logging, and all that stuff is still going to be shared for that project. But you're not going to have 3 or 4 different projects. You're not going to be using project references to enforce the direction of dependencies, which is basically how clean architecture works. With vertical slice architecture, it's kind of there's not as much of a safety net. We know what we're doing, and we trust that we're not going to make mistakes. In which case, I don't know why you're using a strongly typed language with a compiler, because you could just write everything in JavaScript if you know what you're doing and you never make mistakes. But I digress. If you really don't like projects, you could just use one project and folders and namespaces instead and still use clean architecture. Unfortunately, you won't be able to rely on the compiler and things like internal and those project references. Instead, you can still enforce the dependency rule of making sure that infrastructure depends on domain and not the other way around, using an architecture unit test framework. I usually use arcunit.net. There's another one with basically the same capabilities called netarchtest. Either one of these will work. Run these as part of your CI build so that you are catching violations quickly. Here's an example of what a test might look like. So you could say domain types should not reference infrastructure. And if you read this test, it reads pretty clearly how it works, right? And I'm actually using this in one of the modules inside of my modular monolith sample application that's in my my course on Dometrain. So real quick on clean architecture versus modular monolith, and then we'll wrap it up. Whether you're using clean architecture or N-tier or anything else, and you just have a layered architecture with no additional vertical module separation, a problem you run into is that you've got all these nice layers, and they've each got their things that relate to these vertical different concerns. But over time, stuff starts to look like this, right? And it becomes this tangled mess where everything depends on everything else. And it's not modular, and you can't just split off the shipping module, right? Somebody says, hey, let's make that a microservice, and you realize that it's actually coupled to everything else, right? And so modular monolith fixes that. And I'm out of time for this talk, but I encourage you, if you haven't already, to check out more about the modular monolith. Here's some more about me. All the stuff you need for clean architecture is down there in the bottom right. And that's it. So let's see what questions we have.
Well, thanks, Steve. That was an excellent talk, and it clears up a lot of questions that people have about architecture, which is something people often don't get right, which is why I really love that you point out making the right thing easy and the wrong thing hard. I really, really like that. Yeah, anytime you have anything that helps you in coding or architecture, yeah.
And
Yeah,
you
because
know,
if you just have an architect that says, here's the rules of the architecture, and that's it, and it's just like, tribal knowledge, or maybe it's written in a README file or a wiki somewhere, but the compiler doesn't enforce it, there's no way that over time that's going to be maintained, right? You really need the compiler or the CI build or something to kind of enforce those rules in most larger, long-lived enterprise applications.
Geez, even in the small ones, because people, right? Well, I don't have time right now. I will fix this. Oh, BS.
Right.
You never come back to fix it. Have we not learned?
Yeah.
After it's decades of computing, you don't go back and fix it. So, yeah. That was a fun blast from the past, too. I'm looking at a lot of that going, oh, I remember that. Oh, yes, we used to do it that way.
Yep. I added that history section. That's all brand new for this talk, because I figure a lot of developers weren't around for any of that. And so if you're just starting, in like the last 5 years or something, you have no idea that what things used to be like and how that kind of informed the state of things today.
Yeah. Yeah. And it certainly did a lot of the not the best way to do it, and very tight coupling of a lot of stuff. Yeah.
now, see, where do you draw the line between clean code and clean architecture, or like, are they the same, or is architecture a larger concept?
Yeah, they're definitely different. I think the only reason they have the same name is because the person that wrote the books really liked that as sort of a common brand thing. So, like, before it was clean architecture, it was onion architecture and ports and adapters and hexagonal, and they're all very similar and have the same guiding principles. Clean code is a book that has a bunch of advice on how to structure your code and do things like naming, or how long your functions should be, or how many parameters you should have. And a lot of that is very similar to earlier books like Code Complete by Steve McConnell, which is also an excellent book. And it's really more focused on how you write code as opposed to how you build applications, if you will.
So, does the level of formality, we have all these layers. Does it add overhead so far as possibly performance, but maybe additional code and additional ceremony when we adhere to some of these architectures?
It does. Not so much performance. I mean, yes, every method call adds some performance overhead, but that's not typically going to be your bottleneck in any system that's talking to external dependencies like databases. One database call over the network is, a million times slower than a function call. So, you don't really notice the function call performance problem. But it is more files, right? And I mentioned that, and it is more projects. So it does take a little more discipline. There's a little more learning curve. If you're used to just coding everything in one, stream of consciousness, manner in one place, it takes, a different set of skills to be able to refactor that and try to follow single responsibility principle and make things smaller. And clean architecture works really well if you're used to doing things that way, or if you're comfortable doing things that way.
There was a question in chat, and not sure. I think we're trying to figure out what the question meant, but it's something like when you were showing caching behavior.cs,
Hmm.
somebody asked, was this code generated by ChatGPT? And we're not sure what they meant. Probably like, maybe the code is so good or not. I have no idea. But I was going to ask though, when you have good, I mean, no, given your history, you have NimblePros, your company that and so forth, right? So, uh, and folks who don't know, Steve's been, a developer for a very long time and written books and coded many things. So, given your history, having this like single project with this next architecture, do you find that it helps with AI, given that AI can sometimes get lost in the context and, can generate slop sometimes?
I do find that if you're focusing on one thing in a smaller file, that the GitHub Copilot integration and IDEs does work much better. Like when you have any file that's over 1,000 lines long, even 500 lines, it can take a lot longer for it to get the context it needs to do anything useful. And so there are some trade-offs, right? If you ask it to do something that needs to go and span 10 different files, right? That has its own overhead associated with it. But if you have like a legacy controller with 3,000 lines of code in it, and you're trying to ask it about some action method on line 1,700, right? It's going to take it much longer to read through all of that and be able to understand all that context than if you just had an endpoint that was 50 lines of code and had one handle method and just did that little bit of code. And so it's all trade-offs. It's about, with AI, it's about having a small enough context window that is performant and useful and doesn't chew up all your tokens, but still has enough context for it to understand what you're asking it to do. And so it's going to depend on what that task is, whether you're asking it to just I don't know, add a parameter to this, or refactor it, or summarize it and tell me if I should add any tests or fix something, right? Like little things like that about one method, you only need to give it a tiny bit of context. But if you want it to analyze the whole solution, then it's going to be a different type of requirement.
Right.
Okay, Dejan asked, why do you find it problematic to use DB context in queries or commands directly? For most line of business apps, he finds this cuts down on boilerplate code.
I like to keep the dependency rule without exceptions, right? So it's much easier for me to just say that all the things that talk to out of process systems, including a database, live in infrastructure, and all the use cases and domain and everything else will interact with that through interfaces, right? And sure, I could create an interface or use a built-in EF interface for like IDB set or something like that. But now those are violating other solid principles, like the interface segregation principle, which says you shouldn't depend on things that you aren't actually using. And IDB set and the DB context interfaces that ship with EF Core are massive and include every single method that you could ever possibly do. Whereas a well-designed repository interface is going to have fewer than 6 or so methods, and you can use basically just a tiny subset with the ones you want. I find it's much easier to write unit tests if I have that abstraction in place. I find it's much easier if I'm not using something like mediator pipelines to do caching and stuff like that, or logging. I can create a decorator that will add the caching or add the logging. So when I have the interface, it's not just about, oh, am I ever going to change from EF to something else? Or, oh, am I ever going to switch databases? Or, oh, it's only for unit testing. It's also about expanding the different things I might want to have occur every time I do data access. I want to log it in a certain way. I want to cache certain results, right? That's easy to do if you have an interface that you can just add a decorator to. And then you just go in one line in program CS and say, hey, whenever something asks for this interface, let's use this decorator instead. And then with that one line change, you've just added behavior everywhere in your app.
Cool.
Nice. And
So
so,
okay. On the vertical slice architecture, I find it works great with Agile and Scrum practices. And I think, even though you didn't specifically mention this, you did talk about vertical slice as a feature delivery.
Yeah.
Which I think that's where that fits in really well.
Mhm.
But in the back channel, we were talking about this a little. And how would you classify it as the feature delivery different than the architecture itself?
Right. So delivering in vertical slices is something that's been around for decades. And I wrote an article, it was linked on that slide back in 2014, I think it was, about that's how you should ship software. Because if your team is going for 6 months and shipping stuff in vertical slices, you're delivering things that your customer, your stakeholders can actually see and interact with and give you feedback on that whole time. But if you're delivering things in horizontal layers, which was surprisingly common 20 years ago, like you build a .NET app, and the first thing that would happen, because everything was data centric, was somebody would start drawing entity relationship diagrams and defining the database schema, and that would take weeks. And then, meanwhile, the developers start writing the data access layer using ADO.NET, and that would take weeks, right? And only after that, then somebody would start building the business layer on top of that to call all those data access layer things. And so 6 months might go by, and you haven't shipped anything. And then the budget runs out, and you've delivered zero value, right? So the whole idea is don't do that. Instead, ship the whole stack, one vertical slice through all the layers at a time, right? And that doesn't matter what architecture you're using. I don't really like the fact that they called it vertical slice architecture instead of something that's feature oriented or feature folder. Like that's what it is. It's have fewer projects and use feature folders for how you want to organize your code. There's a lot of value in that. But it kind of overrides the traditional meaning of shipping vertical slices.
Yeah, I think back in the day when people started doing that, I think that was a bit of a hangover from mainframe, because that was a way to also ship on the mainframe. You just build stuff for a year, it goes into a black abyss, and the stakeholders have no idea until something comes out, right? And
Right.
then it's like, here's your product, and then oh well, none of it. We don't like any of it, as the customer will always say.
Right.
It's
Yeah.
better to do
Exactly.
that in the small features and keep rolling it out. And amazing how like people still actually are doing some of this today, right? Still hanging on there where they do the whole layer one at a time. So
Yeah. Like I like to say, as software developers, there's two ways we fail. We either build the thing wrong or we build the wrong thing. And building the wrong thing is way
yeah.
more likely if you have a really long feedback loop.
Yeah.
So by shipping vertical slices as frequently as you can, you're going to get a much shorter feedback cycle, and it's going to let you adjust course a lot quicker and make sure you're shipping what the customer actually wants.
Now, I think there's a couple other questions, and if you want to hang around and chat, there's some folks asking some more questions. But we can probably end on this one, which is like, can you recommend any reading material which discusses clean architecture while considering modern frameworks, libraries, etc.?
I'm actually working on a book with a co-author that's going to be out in the next few months that talks about it with Azure and with Aspire and all of that. So that's coming. In the meantime, there are a bunch of books. The Clean Architecture book, I think the original one that's not tied to any particular .NET stack, is from like 2016 or 17, I want to say, maybe earlier. So you can always start with that one. It does a good job of introducing it. But then if you're looking for how to implement it, there's honestly a lot more online courses and YouTube videos and things that you'll find, I think, than books. But again, I have a book that's coming in a few months that hopes to address some of those things.
Awesome. Yeah, folks really enjoyed the talk. And yeah, if you want to stick around and answer any questions, feel free. Um, but
I'd be
yeah,
glad
thank
to.
you
Yeah,
very
I'll
much,
jump
I
Steve.
back
think
in
that's
the
good.
YouTube
Thanks
chat.
again, Steve.
Thanks.